Let's continue with Euler's idea of looking at vertices, edges, and faces of geometric figures. He found the following formula: V minus E plus F. So this is also called the Euler characteristic. And we denote this formula by this Greek letter that is pronounced chi. For most of your examples in task 2, you found that this formula, V minus E plus F, is equal to 1. That means we're after something good. Whenever mathematicians find that they can group the structures, they follow that path to help them understand, identify, and classify the objects they are studying. If we can transform one shape into another, like if they were made out of clay, without tearing or breaking, mathematicians found that the Euler characteristic remains the same. That is what topology studies, geometric figures that are allowed to be transformed smoothly. Let's take a look at these shapes. All of them can be transformed smoothly one into the other. Therefore, they have the same Euler characteristic, and this is equal to 1. I think that the disk has a very strong personality, so we could say that all these shapes are essentially disks. And of course, the Euler characteristic of the disk is equal to 1. One way to see that is because of these smooth transformations and this result that they would have the same Euler characteristic. But now from scratch, how can we compute the Euler characteristic of a disk? Okay, so one possibility is to, instead of reshaping the disk into a triangle, since we are allowed more curvy lines and figures, then we could just put some vertices, like we see in this picture, the edges, so we can count easier the Euler characteristic. So here, if we use this subdivision, this partition, we get, yes, 3 vertices, 3 edges, and 1 face, and the Euler characteristic is equal to 1. And here is another subdivision. In this case, we have 7 vertices, 11 edges, and 5 faces. And notice this is also equal to 1. And still one more if you are more into art and figures and things not having to be so a straight line. This is another subdivision, and we count, and we get that the Euler characteristic is equal to 1. It doesn't matter how you subdivide your shape, the Euler characteristic is going to be the same. Take a look at these shapes, and your next task is pick any figure. Could be one of these, or you just make your own, or if you find something that you like in your house, use that. Give 2 different subdivisions of that object that you chose and verify that the Euler characteristic is indeed equal to 1.